Hello everyone, welcome to Dave Maths Hub. So today we're going to continue on linear programming, but this time we're using shadow cost. So if you haven't liked and subscribed, ensure you do so and turn on the notification bell to get notified whenever I talk about videos like this. That being said, let's get to the activity of today. So shadow cost, this is the amount by which the objective function decreases or increases as a result of the availability of 1 unit less or more of the scarce resources. So let's use an example to illustrate. Now it says Miracle Sewing Institute produces 2 types of dresses. Example, Miracle Sewing Institute. So I told you produces 2 types of dresses. All right. The first one being a shirt and the second being a blouse. Okay. Now it said a shirt has a profit of 800 naira. So we can say this is our profit. But before that, let us represent shirts be represented by X and blouse be represented by Y. So from this now, it said a shirt has a profit of 800, which will be 800 naira X plus. The reason why it's plus is because it's possessing the 2 of them. So we want to know the addition of both. And the blouse has a profit of 600 naira, which will be 600 Y. So it says a shirt requires 2 units of materials. So since shirt is represented by X, we write 2X for the 2 units of materials and 1 hour of labor. Still under X, we write X or you can say 1X. Now, the blouse requires 1 unit of material. Since this is the lane for material, put plus Y. Blouse is represented by Y and 2 hours of labor plus 2Y. All right. Now, it said if 100 units of materials and 120 hours of labor are available per week. So they have given us the constraint. This 2X is for material for shirts. This Y is for material for blouse. And we are told 100 units of materials are available. So this will come as this restrained to 100. Then 120 hours. This is for hours. This is for hours. So this will come as this 120, giving us material constraint and labor constraints. Right. Now, evaluate and solve the linear programming. B, find the shadow cost of unit of material, labor hour, and C, advise the Sewing Institute accordingly. So, in order to solve a question under shadow cost, we'll first solve using the normal maximization way, meaning from our previous video, I have to get the answer to the ending. Then, like I said in the explanation, which is addition of 1 unit less or more, we'll now start doing that part. So before we get to that part, let's solve the normal maximization way. So when I get there, we'll explain. So the first one, let's see, material constraints. When we are giving 2X plus Y is equals to 100. Now remember, in definition when I was talking about linear programming, I say steps to calculating it. I say the first step is to change the inequality to equality sign. That's why here is equal to and here is less than or equal to. So we divide this into two. This first one is when x is equals to what? 0, y will be question mark. Why this one will be when y is equals to 0, x will be question mark. So solving for this first one, this is 2x plus y equals to 100. So this will be 2 open brackets 0 plus y equals 100, and this will be 0 plus y equals 100, giving us y to be 100. This next one, this is 2x plus y equals 100. This will be 2x plus 0 equals 100, giving us 2x equals 100 divided by 2 divided by 2, x equals 50. So next one, labor constraints. When we are giving x plus 2y equals 120. When x is equals 0, y is equals question mark, and when y is equals 0, x is equals question mark. So this is 0, or let's begin this way, x plus 2y first 120, 0 plus 2y equals 120, 2y equals 120 over 2 over 3, y is equals 60. This is x plus 2y equals 120. This is x plus 2 open bracket 0, 120, x plus 0, 120, x equals 0.20. So given this, we have our coordinates to be the first one, x 120. No, starting from this first one, x 50 and y 100, and this next one, x 120 and y 60. Putting it in a diagram, it will be like this. This is for y, this is for x. So the highest for y here is 100, and the highest for x here is 120. So we have 100, 90, 80, 70, 60, 50, 40, 30, 20, 10, and 0. And now we're going to 120, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So when x is 50, this is x 50, y is 100. We'll connect it. And when x is 120, y is 60. We'll connect it. So remember, this first one is for material, whereby we are giving 2x plus y less than or equal to 100. And this next one is for labor, which is x plus 2y less than or equal to 120. So since the question says 4 feet, we're looking at the innermost. So starting from here, this will be our A, which is the first point for y and for x. Going, this is the first one. It is inner compared to this. This will be our B. Coming down, this will be our C. Coming here, and this will be our D. So let's find the corner points. So we have corner points, whereby we have elements X, Y, and profits. So the elements are A, B, C, and D. A, B, C, and D. So for A is touching point 0 for Y and also 0 for X. B now is touching 60 on Y lane. So for X coming from this side to get to this place, it has to come all the way, get to 0 first before it can go up to reach 60. Meaning this 60 is for Y. Tracing it down to meet the junction where X can begin, it meets at junction 0. For C now, that is not touching Y, not touching X, we have to trace it using dotted line. So it's at 50 and 30. So 50 for Y and 30. YD is touching point 50 for X. For Y to get to it, it has to first come down to point 0 before it can get to 50, meaning this one is 0. So we have this. Remember, the profit says for X, 800 and for Y, 600, meaning we have 800 X plus 600 Y that we have to work on. So substituting, this will be 800 open bracket 0 plus 600 open bracket 0, giving us what? 800 times 0, 0 plus 600 times 0, 0 equals to what? A total of 0. Now for B, still using 800x plus 600y. Substituting, this will be 800 open bracket what? 0 plus 600 open bracket what? 60, giving us what? 800 times 0, 0 plus 600 times 60. This is 36,000, giving a total of 36,000. For C, 800 x plus 600 y. Substituting, this is 800 open bracket 30 plus 600 open bracket 50, giving us 8 times 3, 24,000 plus 6 times 5, 30,000. So 24,000 plus 30,000, a total of 54,000. And for the last one, 800x plus 600y. Substituting, 800 open bracket 50 plus 600 open bracket 0, giving us 8 times 5, 40,000 plus 6 times 0, 0, a total of 40,000. Now, this is a maximization question, meaning we are to look at the highest amount being 54 compared to the rest. So from this, we can advise the management should choose option C because Why is he choosing C? 30 units of what? X. You know, X is representing shirts. So write shirts and 50 units of Y is representing blouse. Blouse gives an optimal value of how much? 54,000. When we solved using the normal maximization way, we got a profit of 54,000 having 30 unit of X and 50 unit of Y. So now we will solve using shadow cost, which is an additional unit, to see how we can compare it to what we have here. For the first one, having material constraints, we are told is 2x plus y equals 100 and x plus 2y equals 120. So we can make this equation 1 and equation 2. So for the additional units, remember this first one is material, this other one is labor. So since we're dealing with material, we'll add 2x plus y. After the inequality sign, that is the equality sign, this will become 101. This is the extra 1 unit, making this to be equation 3. Why this one remains the same? X plus 2y was 120. Equation 4. Now, using elimination method, so we'll first eliminate y, giving this one to be times 2 and this one to be times 1 to make this equal. So 2 times 2x is 4x plus 2 times y, 2y, and this is 202. Why this remains the same? X plus 2y equals to 120. Deducting 4x minus x giving us 3x. 2x minus 2y minus 2y is nothing. Then 202 minus 120 is 82. So now divided by 3 divided by 3, we have our x to be 82 divided by 3, 27.333. Now substitute x for 27.333 in equation. Now when we are to substitute, we'll not use these former ones, we'll use the new ones because of the additional 1 unit. So let's go with equation 4. Equation 4, which says x plus 2y equals 120. Now our x has become 27.333 plus 2y equals 120. Collect like terms. 2y equals what? 120 minus 27.333. 2y equals, so 120 minus 27.333 giving us 92.667. Divided both side by 2 over 2. Our y becomes, and 7.667 divided by 2, giving us 46.334. 46.334. Putting this now in the objective function so we can compare it with this original value that we've gotten. Objective function whereby we are told profit is at 800x and 600y. Now, 800, open bracket what? 27.333 plus 600, open bracket what? 46.332. Now, this will give us 800 times 27.333, having a total of 21,866.4 plus 600 times 46.334, giving us 27,800.4 with a total of, so add this to 21,866.4 plus 27,800.4, giving us 49,666.8. Comparing it with original distribution, which is what? 54,000. So what can we say about the difference? Using original distribution, you had 54,000. But when he made an additional increase for material constraints, it reduced to 49,000. So the difference will be 54,000 minus 49,666.8, giving us 4,333.2. So from this you can say, therefore, one extra units of material has resulted to a decrease of 4,333. Let's leave it as this. Thus becomes our shadow cost. Now for labor constraints. Where we have 2x plus y equals 100 and x plus 2y equals 120. This becomes equation 1, equation 2. So since we are dealing with labor constraints, the additional unit will be for the one under. So this will be 2x plus y equals 100 and x plus 2y equals 121. Equation 3, equation 4. Using elimination method. So to eliminate y, this becomes times 2, this becomes times 1. 2 times 2x is 4x plus 2y equals 200, and all this remains the same, plus 2y equals 121. 4x minus x gives us 3x. This becomes 0. 121, 200 minus 121, giving us 79. So divide both side by 3 by 3. X equals 26.333. Now we substitute x for 26.333 in As usual, we're using this new equation now. So let's go with equation 1. That is 3, equation 3. So this is 2x plus y equals 100 to open bracket 26.333 plus y equals 100. So 2 times 26.333 gives us 52.667 plus y equals 100. We call it like terms. Y equals 100 minus 52.667, making our y to be 47.333. Now we put this in the objective function, which says 800x plus 600y. Now we have 800, open bracket, our x is 26.333 plus 600, our y is 47.333. So now 800 times 26.333 gives us 21,066.4 plus 600 times 47.333 gives us 28,399.8, having a total of, so that's 21,066.4 plus 28,399.8, giving us 49,466.2. So we use this against the original distribution when we did our normal maximization. Remember, we got 54,000, and we will look at the difference. So the difference now will be 54,000 minus 49,466.2, giving us 4,583.8. So from this now, we can see when we tried adding additional units for material constraints, we got a negative, that is a reduction. So from the question, we're told A, evaluate and solve the linear program. That is when we did the normal maximization way. B, find the shadow costs of unit of material. That was the first one we did when we added one extra unit. Labor hour. This is this one that we added one extra unit for labor. Now the C part says advise the sewing institute accordingly. So according to this advice now, since when we added extra units for the material, we had a deduction. See advice. For material, we had a deduction in profits of 4,333. For labor hour, we also had a deduction in profits, but this time now of 4,533, which is not good either way. Because the essence of shadow cost is to see, okay, if we add extra 1 unit, will it also increase our profits? But looking at it this way now, since adding extra unit is not even reducing our profits, the advice is the institute should not opt for an increase in either its material or labor hour, because it results to a deduction in profits. And this will be our advice to the management. So should in case you have any question that an increase, when you've tried increase in material, then you compare it with the original distribution against increase in labor, you see there's an increase in profits. Maybe if what we got here was 54,000 and this one is 55,000, you cannot advise the management that they should go for an additional increase in either the material or the labor. So that will be all for today's linear programming using shadow cost. If you have any question you'd like me to solve regarding this or any other one, you can drop it in the comment section. Bye.